Hey, this is Don from Padlock Technologies again with another video. This time it's a question on VRF on a FTD versus multi-instance on an FTD. Which one should you choose? So I'm going to explain the difference between the two. I think I already did the difference between with multi-instances. So I'm not really going to go into depth with that. I'm really going to focus on VRF for FTDs, why people do it, when you should probably do it, and then the pros and cons of it, right? So let's just talk about FTDs and VRFing, right? So VRF on FTDs. Now, if you don't know what VRF is or what a VRF is, it's basically virtual routing and forwarding. Basically, you're separating the routing table in a router. If you do it on a router, you can do it on a switch, and you can also do it on the FTD. So let's say this is the FTD here. Now, when you do VRFs on an FTD, you split the routing table into how many ever VRFs you have. So let's say you have 1, 2, 3 VRFs here. Or we'll say you have 2 VRFs because one of these are going to be the GRT, which is the global routing table. Then you'll have VRF1, and then we'll do green. VRF2. Now, these routing tables are completely separate. They cannot see each other whatsoever. Still in the same box, but separate routing tables. Same as on a router. If you had certain separate VRFs, they can't see each other. Now, this also goes into MPLS. If you're doing MPLS L3 VPNs, then you know that you're going to separate the traffic via VRFs and VPN v4 or v6 tables, right? Now, there are some caveats here when you do this type of setup on an FTD. Certain things you can't do. For one, site to sites and RE VPNs can only happen in the global routing table. So you cannot do that in VRS whatsoever. In fact, if you try to do it, it will yell at you and say, we cannot apply this to a interface that is in the VRF. So you would have to have a design where your outside interface, the one that's going to your ISP, would have to exist. Let's just put ISP up here in the global routing table. Now, what does that force you to do? Now you're going to have to link routes in between VRFs. So let's say VRF1 was, and I've done this design before, production servers. All right. And then VRF2 was, what kind of environment would be our DMZ or something like that, or another network. Let's just say another network. Now the problem with this is now you're going to have to do route leaking in between the VRFs. So the ACP though still applies. So the ACP, even if you do all this, let's just do a square here. The ACP still applies globally. So there is not an ACP for the VRF specifically. So that's another headache that you're going to have to deal with because the routing may be separate, but the ACP and the ACE, or the access control entries, are still in one place. Okay. So now, like I said before, your site to site VPNs, your RA VPNs would come in on the global. And then what you would have to do is leak from the GRT in the VRF and vice versa, VRF in the GRT. And you would have to do that for each and every VRF you have if you need to get to the outside world. Now, that's if you only had one interface in the global routing table. If you had multiple interfaces that would go to the ISP here and here, and this technically can go to the same ISP actually. All right, this can technically go to the same ISP. They would just be in a different routing table. This would be strictly though for like internet access. Because like I said, you cannot do RAVPN or site-to-site VPNs directly into the VRF. They have to be in the global routing table. Where can this become a problem? When you're doing OSPF. So let's say, or any kind of dynamic routing protocol, not just OSPF. So let's say, and I'm pulling this from directly building an environment like this. Let's say you have a switch down here. And that switch has it has the same two VRF tables. So you got your GRT will go here. The production servers will go in here. And then DMZ or another network will go here. Let's say this is a bunch of VLANs. You got VLAN 2 through 10, VLAN 11 through 20, and then VLAN 30 to 40. Something like that. Now, if you're running something like OSPF, I'll use OSPF as the example for this one, and you're running it in separate VRFs in the core switch or whatever switch, could be core distribution, collapse kind of core design. And you have, say this is global routing table. This can be VRF1, VRF2. So you would have OSPF 1, then you would have, I'll do it over here. And this would be OSPF 2, VRF 1, or we'll just say it VRF1. That's the name we'll call it. And then this one would be OSPF 3, VRF, VRF 3, if you want to call it that. Now, what's going to end up happening is when routes go up to the GRT from here, so VLAN 10 through or 2 through 10, that's going to be in a global routing table. If you want the global routing table to now talk to the production servers, you're going to have to create a static route that leaks. This is leaking multi-directional. So these static routes would have to come over, or these OSPF routes that are in VRF1, you'd have to leak them into GRT, and then you'd have to do redistribute static because they're going to show up as static routes. So what you basically do in the FTD is you would say, hey, to get to, let's say this network was like 10.1.10/24. And let's say I'll just use a network over here, 10.100.10/24. And each VRF, you would have to say in the GRT, it would go 10.1.10/24 is in VRF1, right? And then when you do redistribute static, that would show up in the routing table in your core switch down here, or collapse core down here. Then you'd have to do the same thing here to say, hey, to get to 10.100.1.0/24, that would go to global. And then when you do redistribute static in the VRF, that route would show up in VRF1 routing table in the core switch. This can be a huge headache from a firewall management standpoint, because the main problem I see is people forget to redistribute the routes when they want something from another VRF to talk to another VRF, right? They forget to do the multiple leaking of the routes. And then what ends up happening is they end up looking at the ACP. They usually end up looking at this first. They'll look at the ACP first. and they'll say, hey, my ACP rule allows the traffic. So why is traffic not working? Why am I not seeing the traffic go where it needs to go? Well, it's normally, I would say 9 times out of 10 is you forgot to leak the routes between the VRFs, right? VRF to VRF or VRF to global and vice versa. And where this really can bite you in the butt is if you're doing RAVPN and what they're trying to reach is in the VRF, because now you also have to make a static route. You have to make a route in the VRF table to say, hey, to get to the subnets, let's say the subnet was over here was 192.168.10.0/24. I just use 24 a lot for simplicity's sake. Now you in the VRF1, you'd have to say, hey, to get to 192.168.10.0/24, you need to go, let's use white. You need to go over to the GRT, and then the GRT will say, okay, that's a VPN route that's obviously coming from a VPN, right? And then the vice versa is going to have to happen. Hey, to get to production servers from GRT, I have to go to VRF1. So you can see right here, we're doing the VRF technique on an FTD. It's not problematic. It's just a lot of overhead when it comes to making sure the route was there in the beginning. Make sure you're redistributing it down to core or collapse core if you're doing IGP. If not, you're just going to have to do a bunch of static routes. Then you have to realize that RAVPN and site-to-site VPNs cannot connect directly to a VRF. It has to go through the global routing table and go into your VRF via the leaking. Your ACP rule also has to match. Where is it coming from? Where is it going to? But even if the ACP rule matches, if the routing doesn't match, if the leaking does not match, the firewall will not know where to go. And that's the big headache of this. Compared to multi-instance, where you can chop up a security module, which is called an SM. You may have SM40. That means it's 40 CPUs, stuff like that. You create your resource profiles, and then you can chop up your SM module using your different resource profiles, and you can have a small FTD that's 10 CPUs. Then you have your medium, you could say that's like 20 CPUs, and say a large is like the whole thing. But if that's the case, you might as well make it a native instance if you're gonna use all the CPUs. But at least if you chop it up that way, it's one FTD per instance you create. So you don't have to worry about all this weird route leaking and stuff like that. But this is all barring that whatever network design you're doing, because you may not have something that needs to go through another firewall to get to where it's going. And multi-instance has its own design flaws in it. But it also depends on the architecture that you're going to use. But this here will bite you in the butt if you don't know where to look when there's a problem. 9 out of 10, it's going to be, did you leak the routes between the tables? Always check that first. Number 2, if you're doing an adjacency downstream, are you redistributing from the FTD down? Because if you're not doing that, you're not going to see the routes, because you got to remember these are static routes. So static routes don't just magically appear from the route in the routing table. So you're going to have to redistribute it down. Those are the 2, right? Now, where do I see this design the most? Where I see this design the most is when you want GRT and guest access. So if you don't have a separate guest infrastructure that people can get onto that, and they're not really touching your production network or going through your production network, you may be doing some. The other technique you use is guest anchoring, but you're not doing guest anchoring and everything is still using the same network. Then at the firewall would act as a DHCP server. You would split the firewall from a routing table perspective. So there would be a guest VRF, and then everything else would be global routing table. And then you can have an inside interface for guests, outside interface for guests, and they would never even remotely know how to get to your global routing table because they're completely separate. They go out the firewall, perfectly fine, right? This kind of removes any kind of fear of, hey, if I'm on a guest network, can they jump over to production network? Well, if you keep it all with layer 2 up to the firewall, you don't have to worry about them bypassing the firewall for that. That's number one. Number two, if they can't see the route because the routes are not in the same routing table, and this is where splicing up the routing table will help you from a security standpoint. Now, it's again, this is traffic separation. They cannot see the routing table or the global routing table, so they can't see whatever routes are in there. The possibility of them hopping over to the production firewall network or the production network, GRT network, is pretty slim, right? Now, if you really want to get super secure about it, not only do you separate the routing table, but then you deny all traffic via ACP and say there's no way they can talk anyway. Even though they're not going to be able to see each other, if you want to add extra security just because you want to be paranoid like me, you can add an ACP rule that blocks all guest access to production network, and then you're fine at that point. Could you do that without doing the VRF? Yes, you could do that. But again, those routing tables are all going to be seen in the global routing table. But again, from an enforcement standpoint, you can use an ACP rule to block all that, right? This is mainly for, hey, I don't even want my guest network to be able to see any production network that's on my firewall or global routing table network that's on my firewall. So this is VRFs on a FTD. Hopefully this video was informative. Don't forget to share, comment, like, and subscribe. If you are someone that is in the market for or getting an FTD and you're looking for someone to help you with implementation, maybe do a managed firewall for, security purposes, and I would say that blanket for, hey, just in case your firewall person goes on vacation, you need somebody that's a backfill. Link in the description below. Let's do a discovery call and let's see if I can help you or not. It's Don from Padlock Technologies. Thank you and have a nice day.